Question 7. Sunlight of intensity 0.6 kilowatts per meter squared falls on a patch of ice. The ice absorbs 20% of the light. The water produced runs off the surface without being heated above 0 degrees Celsius. Calculate what thickness of ice would melt in 1 minute. Okay, so if we picture a meter squared of ice, then in 1 minute, we can work out the amount of energy that's going to land on it. So we know that there's 0.6 kilowatts, so 600 watts, 600 joules, that is, each second. So in 1 minute, 1 meter squared of ice receives, so it's 600 joules each second, but the minute is 60 seconds long. So that is 36,000, isn't it? 36 kilojoules. But it only absorbs 20% of the light. So go in 1 minute, 1 meter of ice absorbs 0.2 times 36 kilojoules, which is 7,200 joules. So if we're thinking about how much melts, then we need a volume of ice, don't we? In our meter cubed, if we sort of add a thickness to it and call this thickness T, then the volume of the ice melted will be equal to 1 by 1 by T meters cubed. So we could just say it's going to have a volume effectively equal to its thickness in meters. We know for ice that it has a density of 1,000 kilograms per meter cubed. So the mass of ice melted should just be equal to its volume times its density. So the mass of ice that will melt is 1,000 T, and that would be in kilograms. So we're pretty much there, I think. So now we can use our specific latent heat equation. E is equal to ml. The energy transferred is 7,200. We want to find the thickness, don't we? So let's put our values in first. 7,200 is equal to 1,000 T times, so we want the specific latent heat of fusion because we're changing between liquid and solid. It's 334 times 10 to the 3. So the thickness should be equal to 7,200 over 334 times 10 to the 6. Once we put this extra factor of 1,000 in here. Is 2.2 times 10 to the minus 5 meters.